To have a large enough launch vehicle to send the supplies, to send the spacecraft, and other things that you'll need to be able to sustain that. So we have to build this. We have to build it smart. We have to build a vehicle that will allow us to put the payloads, the cargo, and the spacecraft in space to the location that's desired, and have the ability to provide the supplies for that long-term duration. As I spoke earlier, most important thing is safety. Safety is paramount. And a lot of times safety not only drives our cost but drives our mass. We need to do things smart. We need to decide when enough is enough. We need to design something that will meet our needs, but we don't need to try to design the perfect vehicle because we'll never get there. So.
Okay. Let's see. This question. I'm going to actually ask this of all four of you. What is the core purpose? This comes from Facebook. What is the core purpose of this exploration for humanity? Why are we doing it? Why are we building? Why are each of you, making the sacrifices you are, building your career around this goal of deep space exploration? Why do we do it?
Well, for me, I think exploration is a desire it's in the human heart. People want to explore. And I think true exploration takes the government. It takes the resources of a government to do true exploration. From the time of Lewis and Clark, when President Jefferson said, we want to send you guys out to do exploration, to find a way to the Pacific Ocean. He didn't say go there and set up some shops and make some money. It was true exploration. We didn't know what we didn't know. And then when he sent them out, we found new kinds of plants, new kinds of animals, and we were better as a country for that. I think the same thing holds true with space exploration. We don't know what we don't know. And when we find those things, when we make those discoveries, we're going to be better off just as a people, but also it's going to have applications that help make our life better.
Yeah, that's exactly right. I think also when you look at some of the more near-term, or I'd say not too far from Earth discoveries, like going to Mars and looking at whether there's life on Mars. I can't imagine anything more fundamental to our understanding of our life and what happens here on Earth if we were to find and discover life on Mars. So, and having people as a part of that exploration, I think is going to be critical. So I think that's just one example. Also, I think it's important as far as to be a great nation. Great nations lead. They lead on things that are hard to do, like exploration. I think the best example is for those countries that don't have that exploration capability, the time and effort they're spending to get it. I think China is a great example. So I think it's something that, as a great nation, as a leader, we need to keep leading in exploration.
And from an overall country perspective and an agency perspective, if you look, when you try to do something that no one else has done, try to go somewhere no one else has been to, you create an environment where people become innovative. They come up with new ideas, new approaches. It becomes a pull technology where you develop the technology in order to reach your goal, and that technology ends up benefiting mankind. So, the things that came out of the early space race, the things that have come out of the Space Shuttle program, as well as the International Space Station, I think benefit all mankind.
Oh, I think it's mostly been said, but I think it's human nature to want to discover. Discovery is what humans benefit from, what humans pursue, and learning is part of that discovery process. So for us, it's developing a capability, learning, discovering, and pushing the bounds of what the human race has done to this point.
I think I have another question for all four of you, actually. I think you'd all have different and interesting examples. And this is from Twitter, and it's, can you give examples of which technologies from the Apollo and Shuttle are used in Orion? But I actually want to expand that just a little bit. So the legacy, what are you building on that's hardware, that's practically speaking related to Apollo and Shuttle, that's actually helping you do your jobs and that you're using to move forward?
So there's a couple of things I would start with is the shape. Okay, you look at the shape of Orion. It's very similar to Apollo. We've done a lot of studies on different shapes, and it turns out this shape is actually very close to the optimum for this kind of deep space and the entries that we're going to do. So I'd say we learned a lot from that and checked it again and found out that those guys got that part right. There's a lot of things we learned about radiation, about the lunar dust, those kind of things that we do take into account when we do our internal systems design, because in the long run, we hope we're going to be going to other bodies and need to be able to accommodate those kind of things. Beyond that, though, the internal stuff, computers, guides, navigation, and so forth, those are really state-of-the-art. We've taken the latest updates for highly reliable computer systems, networks, and those and accommodated them into Orion. So I look at it as from the outside. Cars from the 50s and today look pretty similar. They have 4 wheels, they have a steering wheel, but the insides are fundamentally different. That's much more like where Orion is today. So the shape is the same because that still makes sense from a physics standpoint, but the internal parts, the part that actually keeps the crew safe and gets them to where they need to go, is state-of-the-art.
And I guess a lot of times we think more toward hardware technologies when we talk about technology advancements and things that we use today. I think one of the things that we've learned most from our early missions in the past is the technologies and analytical tools. The tools that we use today are so far advanced from where we were, and a lot of that came from the early work that came from the Apollo program and others that allowed us to not only test but predict what the results of the test would be, verify those tests, and use those advanced analytical tools to predict off-nominal events so we could deal with them in the future. So to me, the tools is a real technology advancement.
So I really like this question because we've done a lot of study on the Apollo program and the Mercury program and Gemini programs, and as things have evolved, how they ended up choosing the assets that they used and the processing techniques, much of which have been developed over the years. But fundamentally, like Mark said, with the shape of his spacecraft, ground processing requires the basic capabilities to service, to test, and to launch. Those things we looked at, things like transport mode, things like where you integrate a vehicle, integrating a vehicle vertically versus horizontally. We studied all those items and looked at the best capabilities and ways to do it. Now, sure, you have modern capabilities, launch processing systems, command and control systems. All of those things make what has been done in the past far more integrated and better in today's environment. But fundamentally, we're still the same. We're using a crawler to get out of the VAB and transport it to the pad. Once it gets to the pad, it goes through a basic systems test to make sure it's integrated well with the servicing systems at the pad. So a little blend of the old, blend of the new, but they were pretty smart guys in the Apollo era that came up with this.
Yeah, I think I would just echo that. I think the theme you're hearing here is we take the best of what we had in the past and we add to it today's technologies, and we've done that over and over from the basic design, from having a launch abort system and having the capsule on top of the rocket. That increases safety. We learned that the hard way, and we're going to implement that. How we do operations, how we do spacewalks. We've learned how to do spacewalks over the years, and we know how to do that better and better, how to build spacesuits, and then how to operate in space for long periods of time like we're learning on the space station. We're going to put all that to work to make this program work.
A question that came in from Twitter. Will Orion, as currently envisioned, be able to endure in orbit around Mars for the 3 years required for human surface missions?
Today, the Orion systems, we've designed them to be extensible for 6 months in a quiescent mode. So it could be orbiting around the moon. There's nobody on. If it was unmanned system, the systems could survive for 6 months. What we would have to do once we understand the Mars mission more and the specifics about how long, where we would be going, how long we would be there, we'd have to look at each system and decide what it would take to certify those for longer duration. To find actually a lot of the systems can do that. It helps if we had crew on board. In a Mars mission, I expect that we would, right, in orbit, so they could do maintenance and check those systems out. So that'd be something that we would go look to extend where we started from the 6 months we have today.
Another question from Twitter. Do you think the Orion program will last longer than the shuttle program?
So I believe it will, because I think now we're moving back past Earth orbit. There are so many things for us to do beyond Earth orbit. asteroids, the moon, and onto Mars. Also, this Orion design from the beginning is designed to be flexible to handle all these different missions. So I believe it can adapt, just like there was a lot of adaptation between the early Apollo missions up to Apollo-Soyuz. The shuttle design was adapted quite a bit to then become capable of flying ISS. So I think we're already starting with a very flexible system. So I think it can do so many different missions as America decides where it wants to head, that I believe it can last a very, very long time. And the avionics is easily upgradable as well, so we can add new technology, state-of-the-art computers as needed to keep us in step with the technologies.
Question for Rex, I believe, from Facebook. Some deep space flight missions could require 6 months to a year just to arrive at the destination. How would an astronaut spend his or her days during that year's journey?
That would be a challenge. It really would. You know, the thing about being in space and orbit on the space station for 6 months is that you have the view of the Earth to look back on, and you can see your home, and it's right there. It's going to be a tremendous challenge to take a vehicle like this and go off for potentially a 3-year mission. And it's not going to be long, just a few weeks before the Earth starts receding in the distance, and the Earth is just one of the stars among the many. And I've heard some people say it's going to redefine the meaning of the word loneliness, and it will. But there's explorers out there, the same way we've had explorers in the past that crossed oceans, taken new lives, that have decided that they want to devote their lives to exploration, and they'll do that. It'll be tough, and there'll be times where it'll be a real challenge to figure out mentally how you deal with that. But we'll prepare our people. They'll be excited to be the first people going to someplace like Mars, and I think we'll prepare them well, and they'll be able to handle that voyage.
A question from Twitter. Is NASA working on a crew habitat to attach to the Orion crew capsule for long-duration missions?
NASA's looking at a lot of different options of how to extend the stay of the crew, whether it be to an asteroid or onto Mars. So we're in the very early stages of thinking about ways to do that. Orion, of course, is designed from the beginning to do rendezvous and docking with space station or with a lander, and so clearly we could do that with a habitat. So we're early in those discussions.
Okay. I think this may be for you and David. What will be the primary fuel for both Orion and SLS? Is there any way to go faster by using some type of solar sail?
Okay, well, if you look at our early capability, we're basically staying with current technologies that we have. You know, you have the LOX hydrogen engines, you have solid fuels, you have in-space upper stages. And so from that standpoint, we are staying with existing technology, but we're looking to stretch that technology and get more out of it. I think long-term, we will have to have some sustained additional capability. I think our partnering with the science communities and technology development folks is allowing us to move forward anticipating that. So I think some type of, solar cell, some type of, in-space stage that's different than what we have today. We'll have to have something like that in the future.
Yeah, so for Orion, we use, hypergolic propellants. They're efficient. They work great. We have systems that are built to operate with them. They're less expensive, so that's why it's part of the Orion design, and it does the mission that it's supposed to do. But David mentioned, NASA's also looking not only at the HAB, but let's say solar electric, other means to accelerate these larger pieces out to these far durations. Those take a long time to do that, right? They're not very fast, but they're get us to further destinations. So we are looking at ways of accelerating the cargo kind of things, and then you get the crew there faster because you don't want the crew sitting on those for a very long time. But
got it. This is from Twitter. What are the specifications of the Delta IV Heavy that lead it to having been chosen for the EFT-1 launch?
We all started from the objectives. The objectives of this test were really to stress the heat shield, stress the exploration functions of the Orion. So there were really two launch vehicles that exist today that could get us close to the velocities we need to stress the heat shield. One was Atlas V and the other is Delta IV. The nice thing about the Delta IV is the Orion today could basically sit on top not require